aerospace and defense manufacturing,
machines and automation,
additive manufacturing,
smart manufacturing,
global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing. Visit us at sme.org.
Today's episode is sponsored by Falconry, Time Series AI for smart manufacturing.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. I'm your host, Amy Bryson, contributing lead editor of Smart Manufacturing Magazine. And today we'll be talking about a subject that is getting a lot of attention and has a lot of confusion swirling around it. And that is AI and its impact on advanced and smart manufacturing. And my guest today is a true thought leader in the space, Dr. Nikunj Mehta, founder and CEO of Falconry. And for any of our listeners who don't already know, Falconry is an industrial AI software company that provides time series AI to enable timely actions on things like maintenance, performance, quality, emissions, and energy. And Falconry's AI is automated to run anywhere and work with any data stream. So I want to thank you so much for joining us, Nikunj, and welcome to the show.
Thank you, Amy. I appreciate that warm welcome and really good to talk to your listeners.
Wonderful. And before we get started in our conversation, can you spend a little bit of time giving our audience a brief overview of you, kind of your founder journey, and what really inspired you to establish an industrial AI company?
Look, I am somewhat of a newbie to the industrial manufacturing space. I've only been working on it for the last 14 years. And I joined it before there was industrial internet, before there was any IIoT or platform industry 4.0. So in some ways, I did not know what I was going to be doing when I started working with C3.ai, which back in those days was just C3. And when we were really focused on industrial organizations and their data, and the most exciting analytics that you could do for industrial companies then was which plants should they divest so that they can reduce their energy or resource intensity. I mean, that was the most exciting industrial analytics. Now, it doesn't sound right. I mean, it didn't sound right to me either. But what I realized in that very early stage of working at C3 was that time series data was a new type of asset that was both underutilized but also very difficult to work with. Having spent 5 years before that at Oracle in developing new kinds of databases like NoSQL as an example, one thing I knew was that new types of data create new types of ecosystems to exploit that data. I saw it with blogs and video, YouTube and Tumblr, if you remember those. And so I knew that time series data's day was going to come and that it was going to take a lot of advanced work to turn that underutilized asset into value. And so that is where I got the germ for what became Falconry. And naturally, having done a fair amount of work in both distributed systems as well as in signal processing and artificial intelligence in my undergraduate and my graduate work days. You know, my PhDs in computer science from USC, and they did a lot of work in these areas. I knew that the approach to take was not what database and applications companies in software typically do, but it was more like the signal processing approaches that communications and voice companies would typically do. And so that's where we got our founding inspiration, if you like.
Wonderful. So you really have been in this since really it became, or well before it became, certainly an industry buzz acronym for manufacturers. And so you've been working on industrial analytics for, roughly, you said 14 years, I believe. And I'm wondering what, in the history that you have and the expertise that you have, what your insights or perspectives are about the current state of AI in manufacturing. As I mentioned at the top, we cover this topic a lot, but there still is a lot of confusion and I would say trepidation across manufacturing in, what really it is, how to harness it. Is it really helpful? What tools do I need? It's very complex for a lot of our listeners. So I would love your perspective on where we are currently, in the state of AI in manufacturing?
Yeah, so I think the best way to sort of answer that question is what has not changed in these 14 years? And to me, that is essential to industrial, if you might, analytics. One thing that has not changed is industrial companies have not become any more lenient to share data from their machines' operations. They have always treated it as invaluable and as a competitive advantage, and they will not let go of it. Now, if you juxtapose it against all of the New York Times articles that are being eaten up by OpenAI, you can see the difference. Now, what that tells me is that in the context of AI in manufacturing, it will always remain hard to come up with technology that impresses people, because it will only impress them when it is both automated, explainable, and readily applicable to their problems. Now, these are three things. I mean, they are each very big. They could each be their own companies. But as we've seen from the work of very large companies, American companies, Northern European companies, Central European companies, everybody has struggled with AI in manufacturing or with big data in manufacturing. Mostly it is because so many things have to be just right for adoption to Zoom. And so that is one of the insight I have developed is you have to marry multiple things. You cannot, you cannot just be an algorithm library. It doesn't work. And therefore, what we have had to do is develop something that is unique, that might be proprietary as a result, but that helps people understand how committed somebody is to making this successful, how purpose-built it is, and what is the economic approach to scale it. As you know, there are a lot of lighthouses, but I'm sure you hear also that it's very hard to go from the lighthouse to at scale, because lighthouses are stood up as examples. They're often greenfield in nature. It's very hard to replicate what you do there elsewhere. So given that automation and explainability, as well as design specifically for time series coming from industrial automation, is what is essential to succeed with AI in manufacturing. Now, one other thing I will say is when we started out, we approached this purely from a commercial perspective 14 years ago at C3. Over time, governments have made it a national priority all over the world. And I think I should put in a plug that National Institute of Standards and Technology under Department of Commerce in the US is creating an AI in Manufacturing Institute this year with about $70 million of funding. I mean, that's a first. And it's very specific. It's just AI in manufacturing, what you asked about.
Yeah, I just saw that too. I just read that report that came out a little while ago. It's tremendous. It's such a stake in the ground, and I think the folks at NIST as well as folks over at SESME and the entire ecosystem is really rallying around this notion of helping democratize and simplify smart manufacturing solutions. And I love what you said about the automation and the explainability as it relates to problem solving, because I think that's where our listeners really, their ears perk up when they realize what kinds of problems they can solve with AI solutions. And so I'm wondering, since you and your team at Falconry are at the forefront of AI and innovation, what has been the most difficult or challenging, change or thing that you've seen manufacturers grasp when it comes to adopting AI solutions?
Yeah, Fred Brooks, who wrote The Mythical Man Month, it's a seminal work in software engineering, used to talk about essential and accidental problems. And so I'll use that analogy to talk about what's difficult and what is hard. What is difficult is something that can be overcome. What is hard usually will never change. So what is difficult is that connecting to the sources of data, which tend to be the PLCs and industrial automation gear in any kind of industrial manufacturing, has been difficult. But I'm really glad to see companies like Litmus Automation, and many others that have taken the gauntlet and have hooked up every manner of PLC into a internet-friendly protocol. So data connectivity has been difficult. It continues to be difficult. People are still challenged by it. But I think it is an accidental problem. Also, there's this question of what's the business case? What's the ROI? That's also been difficult. And I say that as a founder, that is what continues to give me shivers at night. But it is still only difficult. I don't think it is hard. And it has become more manageable over time because of automation and because of the suitability of automated solutions like the ones that Falconry has created with patented deep learning in time series for anomaly detection. It readily applies. So business cases have become a lot easier now than they were before. It mattered a lot more when you had to make a business case for a few $1 million to be invested over a few years. And it was a make or break decision for companies. If we don't do it now, we'll be probably overtaken by our competitors. That was the fear. But if we do this and it doesn't really pan out, we'll be 5 years in and $50 million out. And that doesn't seem like a good prospect either. But nowadays, I think the business case decision is much simpler. It's $100K, and in 3 months, I have confidence that this is the right decision and that I can scale it. And so that has become less hard. So these are two difficult problems, but not hard problems. Now, what is hard about AI in manufacturing are two unique challenges to manufacturing. First is there is almost a complete lack of labels that can be used for any kind of AI. Juxtapose this with so much text that is human crafted that you can learn from. It's got grammatical errors, but it's mostly right. It's covered practically anything that human mind is applied to, and therefore it's comprehensive. And everything is a self-labeled kind of text. On the other hand, in the industrial world, you look at all this time series data that comes out of machinery, there is no labels. In fact, even maintenance records that are created, and maintenance managers will themselves tell you that 70 to 80% of urgent maintenance requests are wrong requests. There is really no maintenance to be performed, right? So even where we think we have labels, they are bad labels. So this complete lack of labels is one of the hard problems, and it will not go away. The second is that time series data has a very short half-life, especially coming from industrial manufacturing. Now, what do I mean by that? Data, when it is created, basically in the course of the operation of a machine, is also used to operate the machine, to run a recipe, to perform a control function, to achieve a set point, however you want to think about it. And soon thereafter, that data becomes almost unusable because the machine changes, because what it is working on changes. Now, this may not be true for a motor that is only pumping out wastewater. It does that for years, and it will continue to do that. So in that sense, that data probably does not change that much. But if you think about any manufacturing context, not the balance of plant assets, but the critical assets, those are constantly being maintained, changed, overhauled, being put through into new recipes and processes. Therefore, anything from 3 months ago, anything from 6 months ago, for sure, will not make sense anymore because so much has changed since. So this short half-life of time series data is hard about AI in manufacturing. Therefore, you cannot put together a data bank like NIST might put together a data bank of images, let's say of the various handcrafted or hand-written digits. That's a data bank. You can probably keep it that way, and it's not going to need to change much for 20 or 40 years. With time series data, there is no good way of doing data banks. When you look at a lot of the research that is being done, much of it is done with very poor data sets, where anomalies are hand introduced into the data. They don't actually belong there. They don't randomly happen. They were human injected into it. And this difficulty of the time series data corpus has made it very difficult for people to enter into this field. And so I believe it to be a hard problem.
So what is the solution for these challenges?
So to make it not so hard, we have to get computers to teach themselves. And we have to use as labels that data which is incontrovertible. Now, industrial automation data, which is the tags that are produced by the PLCs, are incontrovertible. Why? Because the machine is running. I mean, there is no two ways about it. So that data is ground truth. If we can teach a computer how to produce ground truth from ground truth while going through a complete 360 or another kind of orthogonal translation in between, then that means the computer actually understood what that data is. In other ways, let's say we had a translation process. So an English person speaking with somebody who's only speaking, say, Chinese and English, that person hears you and then conveys the result to somebody who only speaks Chinese to English. And then that second person tells us back what they understood in English. And now we compare the original English and the final English. If they are identical, that means the translation was perfect. And that means that the translation process was perfect and people have understood the translation process well. We need the equivalent in computers. And that is the only way we can teach computers to understand our world. And that is something that we have been working on for the last 3 years. We have actually introduced this into the product and we are seeing the results of it. You don't need any labels and it doesn't take any time for this kind of a system to learn in its own environment. And it can do so without carrying over intellectual property of one customer into a different organization. That's also important. And it's very hard to avoid in the generative AI world because, especially with public ChatGPT type of tools, whatever you may be asking is also teaching them. And whatever you may be typing may be consumed by somebody who you don't know might be using it. So while still respecting these boundaries in manufacturing, this is what is essential.
Wow, it sounds like you have a lot of new things going on over at Falconry. What else can you tell us of what you're working on that are potential game changers for the industry?
Yeah, I mean, I know that not everything should be called a game changer, but I will say one thing in particular. Our focus on advanced methods, whether it was machine learning at first and now it is anomaly detection and AI, we thought that would be game changing. But what we realized is that the industry needs to have simple things combined with complex or sophisticated things. So Falconry is just now introducing simple things like rules that people have used in the past to do either limits or threshold-based alerting. And you can do that, and you can very quickly start exploiting your data and develop confidence in the AI because of the correspondence between the AI result and the rule result. And in the process, we can gradually start introducing AI into the industrial landscape. So this, to me, is groundbreaking, not because of the difficulty of building rules, but because of being able to juxtapose all kinds of analytical methods, visualization, machine learning of patterns, detection of anomalies in an automated manner, or generation of smart alerts from rules in a single environment is what is groundbreaking. It's almost like you brought together two very famous Silicon Valley companies in the context of data processing like Snowflake and OpenAI in a single offering or in a single package. So that is what I mean will be groundbreaking. Naturally, groundbreaking stuff has to be paired with mundane but important stuff, like make it easy for any data to flow into Falconry and out of Falconry. So we've worked with companies on MQTT integration and UNS, which is the unified namespace, as a way so that we can all speak the same language and that every one of these things becomes just a transducer for the other. Likewise, making it possible for people to use standard BI tools like Power BI on the results of AI so they can do prioritization and understand the business sort of decision-making process. Now, these are other things that Falconry is bringing to market this quarter.
Wow, that does sound truly amazing. And I love the idea of taking these huge innovations and simplifying it for the end user, because I think that's a thing that's missing in the AI discussion right now is simplification and understanding how specific problems can be addressed. So that does sound...
Yeah, and actually I will just say one thing about simplification. We know keep it simple, stupid. We get that. And yet, when we are dealing with such difficult, gnarly, and critical issues, we end up solving hard problems. But it's not until we make it so that people can compare simple techniques with hard techniques and live with the two on an ongoing basis, can we create real adoption and confidence in people? And so I think that lesson should not be lost upon anybody, that to make it possible for people to adopt, give them very simple things that they can understand. In fact, there may have been some fear in the prior years, but I can see very clearly that companies, maintenance teams, as well as engineers who are frontline, all want to adopt AI. You're just trying to figure out what AI is going to be good for them that they can be confident about. And so that's what we have to solve.
Yeah, making it tangible and understanding how it can impact their jobs and, the entire production process. I think that's a very powerful point. So let's switch gears a little bit. So when we're talking about an increasing focus on sustainability, can you talk a little bit about how Falconry contributes to maybe even helping manufacturers reduce their own environmental impact?
Sure. So, Falconry has been focused on time series analysis and time series AI. And our customers have often asked to see whether they could apply it for detecting volatile organic compound emissions or for looking for energy excess usage in a specific process because they were not able to get tooling maintenance performed at the right time. And now it's taking a lot more energy. So in these two areas, so long as there is data available from the PLCs themselves, Falconry can perform indirect determination of emissions or energy usage. And this has been used in a number of resource-intensive sectors to give them early indications that can help people take corrective actions around emissions or around energy tracking. So we believe that this time series AI or condition-based anything, the name as we are calling it, are means of solving problems that go well beyond just maintenance and downtime. And this is a new approach for many of us in the industry. So over the course of the next 12 months or so, we are looking to work with such organizations that want to have multi-dimensional approach to exploiting their time series and industrial automation data, so that it's not limited just to the maintenance team, but also to the sustainability team, as an example. In the end, we know that the sustainability effort is not only about producing a GHG report. It's actually about taking actions that reduces that emission. And taking actions is operations at the end of the day. And operations is going to need evidence. They will need to make it granular. What better way to make granular decisions than to take the exact same data that is running machines to figure out where and when emissions are being affected adversely.
Wonderful. So that's one of the priorities for the next 12 months. Looking ahead, what else is on the horizon for Falconry?
Yeah, I mean, as I say, sometimes technically simple things can make a big difference in the adoption process. And so we are all about removing hurdles and friction from the adoption process. So we've been working on integration with the downstream tools that people need to use to apply AI in their enterprise. As an example, the enterprise asset management or computerized maintenance management systems are essential for people to deploy these kinds of AIs at scale. So integrating with those is one of our key objectives. A second one is providing an interface to executives in manufacturing that is powered by the same AI that is used to guide operations and maintenance teams about actions they must be taking. And this brings the two in synchrony. They then can understand each other better and provide a real-time picture. So this is another one of our innovations that's already being developed, and it is being co-developed with a couple of our customers. And then lastly, making this technology suitable for use by system integrators. As we know, the whole industrial automation ecosystem heavily relies on integrators who bring together PLCs and data acquisition technology. So we are also choosing to work with such system integrators so that they can provide the last mile of service and create, a lot more value for themselves than even Falconry can create for itself. So we believe that this is going to round out much of the work we will do this year. And, I'll save some surprises for later when we have them ready.
Yeah, we'll save some surprises for the next time we speak. But, as the smart manufacturing landscape continues to evolve, as we've discussed, what are some of the trends you see shaping the industry in not just the next 12 months, but in the coming years?
Yeah, I think the first is that, when I started working in the industrial AI space, I knew about historian technology. And then I later learned a lot more about them, and I tried to fit in. And soon enough, I realized that was a lost cause. So I believe we've already seen now so much evidence about an ecosystem that can thrive around common standards or approaches like MQTT, like UNS, so that we can free up the actual storage of this data to more modern technologies. And so in some ways, I think the historian technology infrastructure is more or less now at its glass ceiling. Doesn't mean that it will disappear, but I think that it doesn't have a prominent role to play in the future. And to me, that is going to shape our industry in a very profound way going forward. There was a lot of confusion in the past, but I don't think that there is much confusion left in that regard anymore. The second is that industrial companies are going to sort of only adopt technologies that they can apply at the line scale, not for individual use cases. Again, we are seeing this because the rate at which any individual incident occurs is very low, maybe once in a year. But the rate at which some or the other incident occurs in a line is pretty high. Like every day, there's usually one or the other incident in a line. And so adoption that can be proven to scale is how people are going to make choices in the smart manufacturing context. The third thing that I see also, and this is where my bias comes in, is people are going to want to see a fewer set of technologies and tools to use in their industrial context, not dozens and dozens. And so that is going to create some amount of pressure to become more general purpose and consolidate. And that is also the indication of maturity of these technologies. It's difficult to be both an entrepreneur and be talking about consolidation, but I don't know how to avoid that. And then lastly, I think in the past, a lot of people have chosen to work on many different things. And we've again seen from the failure of giants that even the largest companies cannot do that. So we've all got to be much smarter in engaging with manufacturers through partnerships in much the same way that, what car we buy is usually the result of, 100 or 200 companies working together to deliver that benefit to you. And I think similar partnership approaches are needed even in the smart manufacturing context.
Yeah, that's a wonderful note to end on. This whole notion of, simplifying smart manufacturing, through strategic partnerships, across the ecosystem. A lot of emphasis on that. It's wonderful to see a company like Falconry, putting its innovation and expertise to use to help manufacturers compete and succeed and demystify and simplify things like AI and the potential to make manufacturing stronger and more resilient. So we've covered a lot of ground today. If our listeners walk away with a couple things, what is it that you think they should know?
My main takeaway for the audience is that smart manufacturing cannot be achieved without successfully exploiting industrial automation data. There's just no way around it. And that means that we have to prioritize the ability to access the PLC data from lines, whether that goes through industrial historians, through potentially PLC gateways, or potentially, and this might be supplementary, through condition monitoring sensors. And we have to figure that out, but that cannot be put off into the future. Everybody should be thinking about that now. The second is that smart manufacturing requires an agile mindset, which means take something that is automated and therefore will constantly evolve with our understanding of what we need. Unfortunately, everybody still has a relatively fluid understanding of what they will need to do to succeed at smart manufacturing, which is okay so long as the mindset we are working with is also of an agile nature. We want to apply this, learn, get some benefit, figure out what we need to do next, and run the whole cycle again. These can be a month-long cycles, so it doesn't have to be very long, in which the intense period of execution is 2 weeks and maybe another 2 weeks of planning. And that way, we can actually make a tremendous amount of progress in a year. So these would be my 2 takeaways, is actually figure out how you get the automation data out and start to become more agile in your execution of smart manufacturing.
That is wonderful advice for our listeners. Well, Nikunj Mehta, I want to thank you so much for taking the time to join us today and share your valuable insights with our listeners. And if people want to learn more about the work you and your team at Falconry are doing, where should they go?
I would suggest 2 resources to them. The first is the Falconry website, falconry.com. It's Falconry with a K, not a C. This website gives you information about the unified smart manufacturing architecture and how you can go from data assets in the industrial manufacturing context to actions, maintenance, reliability, quality, and so on. The second resource, and this is one that I keep very close to my heart, is the Falconry blog. We have been publishing very regularly now for many years, and much of what I have said today is just a distillation of what we've said there. And so the Falconry blog can be accessed at falconry.com/blog, and you can subscribe to our newsletters so that you can see when new articles become available.
Wonderful. Well, I also want to thank our listeners for tuning in, and make sure you check out all of those resources and prescriptive guidance on the Falconry website. And make sure to stay up to date about what's happening in advanced and smart manufacturing, and hear more podcasts by visiting us at sme.org.